Okay, so we'll talk about MapReduce. We'll go over it one more time. So the MapReduce is a model for programming in this distributed environment that we've been talking about. It works like a Unix pipeline. So it has an input, then maps. So some functionality we can implement into this function map, then either shuffles or sorts, and then we implement some functionality in the reduce function, and the output is produced. So some commands that can perform this, grep can search for some strings in the text, for example. Sort can sort words or numbers. So there are other commands that can match for the reduce or for the output that is being produced. Let's see how the data flow looks like. So this is first node. In the node we have mapping processes. So we're going to take input data. It will be divided into a mapping process or into pieces called mappers. And this is intermediate data that is being produced from these mappers. When the data is produced, there is a key value pair, and these values and the keys are exchanged by the shuffle process, and then they are sent to the reducing process. The reducing process can be on another so we have a number of mappers and a number of reducers. So the reducing process will obtain these values and keys that were produced by the mappers and that have been shuffled or sorted, and run its function on them. And finally, the output is created and is stored locally. Now, this is node 1. There could be many other nodes, node 2 or 3, that are involved in processing of the input, because the input can be one file or it could be a set of files, and each node will get one file to process. That's why you see this from node 1 mapper is going to node 3 reducer, or node 2 mapper is going to node 3 reducer, or node 3 mapper is going to node 1 reducer. So they could be the mappers and reducers running on different nodes. So when we do that, it allows us to do load balancing. This way, not all of the computation is happening on a single node, but it's distributed and the load is balanced. And so if there is too much load on a particular node or a subset of nodes, we have a way to transfer this load into other nodes. If any of them fail, the environment, the distributed file system environment, will take care of that and reassign the execution to another node. And some local optimizations can be done, such as the number of files that are stored in directory in this particular node. Optimizations in terms of the network bandwidth that is used to transfer the data between the nodes, and then this Hadoop distributed file system with MapReduce running on it is an effective solution for batch processing and for some stream data. So, an example with word count, we have seen that briefly last time. The input will be a value and key pair. The value is lines of text, and the key is a word. The reducer will take also the key as a word, and the value will be set of counts, and the output is sums these counts. When we launch this program, that's going to be perceived by the cluster as a new job, and so this new job is submitted to the cluster for processing. So this is what happens. Let's say the text contains some words: deer, river, car, beer, and some other words. First thing that happens is splitting one line, the next line, and the next line. The mapper will take this as a key and count. Over here, deer is only one time, so count is 1. Same for beer and river, only one time. Same will happen for the next line. Key and count, key and count. Those are then shuffled. In this case, they are sorted because all the beers are together and the count is 1. The cars are all together, the count is 1, and beers together, count is 1. So these are sorted by the key, and then reducer, it's gonna, for that particular key, take the list of counts, add them together. So we have 2 here, we have 3 here, again 2 and 2. And the final result is the word and its count. Yeah, this is an example of code which does what I have just shown you. This is the map function. Extends MapReduce base, implements mapper, and this is the parameters that it takes. Then the map takes the key and the value. It uses a string tokenizer. The reduce, the same thing. Implements reducer. And then it takes the text and the list of integers and just adds them together. Some parameters need to be configured to run this because the framework defines some attributes that control how the job is executed. So configuration set, job name, you have to give a name to your job. The applications can give arbitrary values to this job, and the job is available to all the tasks. So what we're doing is creating and launching a program for our application. When we launch this program, it will configure a mapper and a reducer that we're going to use, and the output key and value types. It will infer those from the input format. Once this program is launched, it submits it as a job. And these are batch jobs, so the first one came, the next one, the next one, they're queued, and they're done one by one. So this is more configuration parameters. job. So we're gonna set output key, output value, mapper, combiner, reducer, and the input and output format, and then the path. And once we set those, we can run the job. We can specify how the input is read if we want to. How many of these mappers and reducers are we going to get? So usually we have as many as the number of blocks that is being processed, and so the block is 64K. It could be 64 megabyte. It could be 128 megabyte. We can change that size if we want to, and so as many blocks we have, that many mappers we're gonna get. We can control that through this minimum split size for the mappers. Unless the amount of data is being processed is small, then the reducers is 0.95 times the number of nodes.